This is some information about some general rules for solubility. Substances that tend to be soluble. And these rules should be applied in order. Rule number 1, all acids are considered soluble. An acid starts with H and is followed by some anion, some negative ion, or it ends with COOH. All acids are considered soluble. Rule number 2, all compounds that start with sodium, potassium, or ammonium ions, and all compounds that end with the nitrate ion or the acetate ion are soluble. In fact, you will see a lot of drugs that are sodium something or potassium something because most of those compounds are soluble. The rest of the rules are not all rules, but they are most rules. The next rule is that most compounds that end with chlorine, with bromine, or with iodine are soluble. But because this is a most rule, there are some exceptions. And the exceptions are mainly silver, mercury, and lead compounds that, for example, lead 2 chloride or mercury 2 bromide or silver iodide. These are not soluble. And the fourth rule is that most sulfate compounds, so if a compound starts with SO4, most sulfates are soluble. There is a notable exception to this, and that is barium sulfate. In fact, barium sulfate is used in GI x-rays because it allows the x-rays to see into those soft tissues, but the barium sulfate itself is not soluble. It's like drinking chalk water. The barium doesn't dissolve, therefore the barium doesn't get into your system, as it would be poisonous. And then the rest of the rules are for insoluble compounds. So rule number 5 is that most hydroxides, carbonates, and phosphate compounds are insoluble. Now, these rules are applied in order, so if you have sodium hydroxide, it's soluble because back here in the sodium compounds, you already decided that your compound was soluble because it started with sodium. But most other of those are not soluble. A couple of exceptions to this are calcium hydroxide and barium hydroxide, which are soluble. But for the most part, hydroxides, carbonates, and phosphates are not soluble. And then rule number 6 is that most elemental gases are slightly soluble. And these are things like oxygen, helium, nitrogen. And they also include something like hydrogen sulfide and actually hydrogen cyanide also. So those are just a couple added ones to that. You can use these rules when you're looking for those precipitates, where you take two substances that are soluble, and when you mix them together, you get a solid because you get two ions hooking up together and making something insoluble. So that's just a review of those solubility rules. A couple of examples, I didn't want to go that far. Iron hydroxide, sodium carbonate, calcium chloride, and barium acetate. Are they soluble or are they not? What rules would they go under? Here's the iron hydroxide. When I look through here, I don't see anything about iron, but I do see that most hydroxides are insoluble. It doesn't fit any of the prior rules, so this is insoluble. It will not dissolve in water. Calcium chloride. When I go down through, the first thing I see is I finally see a chloride, and it says most chlorides are soluble. It's not an exception, so calcium chloride should be soluble. Sodium carbonate, there's sodium. All sodium compounds are soluble. This is soluble. I don't go any further. And the last one is barium acetate. And again, all acetates are soluble. I don't need to look at what it's hooked up with, so the barium acetate is soluble. So that's an example of using those solubility rules.